Well, hello guys, welcome back to Cosmic Simulations. Well, something very exciting and interesting has happened in the latest simulation I have been working on. And in this video, I'm going to talk about that. I created two galaxies, not very far from each other, but not too close either, but with a twist. If you remember, the last video was all about order when the universe was created with perfect orbital velocities, and the planets and the stars kept circling perfectly in their original orbits, even after years of simulation. Well, in this video, I have injected some intentional defects into the order. I wanted to create chaos, and this time, to do that, what I did was I varied the what was supposed to be perfect orbital velocity, I varied it by plus minus 5%. And as you can see, those two different galaxies, which were created at some distance from each other, and they were in fact two very different galaxies to start with. From a distance, if you saw at the same structure, they will look like they actually are one. As you can see, many of the planets seem to have escaped the original intended orbits of their stars, and many of the stars have escaped the original intended orbits around the center of the galaxy. Let's zoom out and see how far have those planets and stars escaped. As you can see, quite far away actually. So let's stop here and see the farthest one. The farthest planet I can see is this one. Let's click on that and let's click here. That's quite far away from the core, the center of those two galaxies, isn't it? Something quite violent must have happened with this with this planet to have escaped so far, probably because of the imperfect orbit. It veered around the center of the galaxy near one of the black holes and got ejected after circling or kind of taking a slingshot around that black hole. We don't know. I'll have to find a way to probably record these interesting events as and when they are occurring, because you can't really keep recording it 24/7, because this simulation has been running for 15 hours and one of those events happened anytime in those 15 hours, and of course I couldn't record that specific interesting event. So I'll have to find a way to record it at the exact right moment. But as you can see, this particular planet has escaped quite far away from the center of those galaxies. Let's zoom in. Let's travel closer to the galaxies and see what we find. As you can see, I mean, from this distance, it hardly feels like two different galaxies, right? It feels like that's a single structure. And that happened only because of that imperfection, right? I tried to create chaos. Well, it has created chaos, but in the cosmic scale, even this chaos looks beautiful, right? So if we look at, well, to start with, we created 7,257 objects. 6,960 have survived. Well, some of them have collided, right? But there have not been many collisions. I expected more, actually. I expected more collisions. But what has happened here is because the space between two stars and planets and the stars is so huge that even if the planets escape the orbits of their stars, even when the stars escape the orbit of their galactic center, they haven't collided. They have kind of squeezed past between the other two objects and survived. They haven't collided at all. But some of them have traveled quite far from their intended original positions. To an extent, they have kind of like as if you put the two galaxies together in a jar and shaken it quite a lot. It's like while you're making a drink, all the ingredients get shaken up, right? So that's what has happened here. Um, the two galaxies have almost merged with each other because of that imperfection that was injected into the creation time while creating these two galaxies, right? So let's take a circle around it. And what we are going to do is we are going to travel to the center of one of these galaxies. Let's lock onto this view. And we are going to lock on to one of the central objects there. And let's see what we have locked onto. So you can see I have locked onto the heaviest object in around this area, which is galaxy black hole 0. So what we are going to do is we are going to travel towards it, and we are going to take a close view of that galaxy from there and see how it looks like, right? So let's stop there and let's start circling. So we are circling around the black hole. Let's try to get the other galaxy into the view. I think it's somewhere around there. That's just an intuitive guess. Let's go a bit closer to that black hole. As you can see, after some time, everything else will stop. Just that black hole is moving, nothing else. Okay, so let's stop there. Let's lock out of the view of that black hole. And I'm trying to look down onto the other galaxy to see if I can get that into my view. Yes, that looks like the core of the other galaxy. Okay, so beautiful, isn't it? Yeah, so I am in this galaxy looking at the core of other galaxy. I'm very near to this black hole. Well, I'm glad that's not a real black hole. Otherwise, I would have got sucked in long back. So let's circle around this black hole and see the view of this galaxy and the other galactic center while I'm circling around this black hole, right? So let me stop here for a moment. Something interesting has come up. So you can see this particular highlighted object here. So if I click on it, well, the simulation highlights an object if it is the heaviest object, or if it is the fastest object, or if it is the farthest object. So you can see in this instance, this is the fastest object of all. And this is planet number 2 of the star 549 of the galaxy 0, right? So you can see planet 2 is indeed the fastest object, right? That's why it has been highlighted in this color. So it's moving at a speed pretty high, right? So, in the simulation, I haven't implemented um, the theory of relativity. So it wouldn't be surprising that you might find one of the objects traveling either closer to the speed of light or much faster, because the theory of relativity has not been implemented as part of the simulation. That's an objective. We are going to do that sometime. I lack the knowledge to do that, but we are going to find a way. If you have the knowledge of theory of relativity and how to formulate it in mathematics, please don't hesitate to get in touch. Probably we could work on that together, right? So, but yeah, this object is traveling really fast. Probably I should convert these speeds into um, taking the reference of speed of light, or taking the reference of speeds that we have, our brains can comprehend, right? Because when I read this 1.9 e to the power 9 meter per second, I don't know what it means actually. So that's a refinement we'll have to do. So we will have to just yeah. So we were going around that black hole. So let's continue our journey and try to get back the other galaxy in our view. So we are here, and that's the other galaxy in our view. And from here, we can either travel closer to the black hole, not too close, and we can go away from it. So as you can see, some of the stars were moving much faster as we are going away from that black hole than the others, and that's because we are quite close to. So let's stop there and zoom out from here. Yeah, so you can see these ones, they are moving faster than the other background, and that clearly says that probably well, actually these are part of this galaxy while the other galaxy is in the view. So you can see. Yeah, so let's zoom out again. Let's travel away from it and safely, from a comfortable distance from the black hole, we can circle around the structure again. Now, one interesting thing that has happened as part of this simulation is you don't know which planet belongs to which galaxy, which star belongs to which galaxy. We don't know, because they are kind of merging together. They have lost their distinction, right? So if we, especially in this area, if we went closer and investigated one of the stars and see which galaxy does that star belong to, and if the planets of that star are still with that particular star, or they have escaped the star altogether, or they are the planets of a completely different star, or they could be the planets of the star belonging to a totally different galaxy circling around a new star. So we don't know what we are going to find. So let's go and check. So we are going closer. Let's try to zero down onto a star in this area. So let's stop circling. I think this star is a good candidate. So let's point on that and let's go near that star. Okay, so we are going near that star. As you can see, we are going near. Nothing is moving at all. Soon I'm expecting that star will start becoming bigger, which it is. So the only way to distinguish from here that a planet belongs to this star probably is when we are moving away or going towards it, that particular planet will move faster than the rest of the background. And that's when we know that that planet is near this star and somehow associated with this star, right? So let's go away from here. Let's see if one of the planets start moving faster. No, not at all. Not at all. I didn't find any planet moving fast enough. So let's say if this, I look at this planet. This is planet 7 of 372, and this is star 133. This planet is too far away from here. If I click on these two, one after another, it will give me a distance. Yeah, so that's too far away. Um, so they don't belong to the same. I mean, they don't. This planet is not circling this star at all. If I go near to it again, no, there's nothing that's moving fast enough. So I can't really associate that particular star with that particular planet. So let's go away from the star. Let's see if we can find a suitable candidate which still might have planets around that star, right? So right now I'm traveling away from the star, and okay, this one is moving faster, so this star is not too far away from that star. So how about we lock onto this one? There are some planets around it. I don't know if those planets belong to this star, so let's go near it and see what we find. Is there anything moving fast enough while we are traveling towards this star? Not really. So probably this star might have lost its planet. Well, two possibilities. That star might not have any planet at all because, again, the entire universe was created randomly. Or it could be that the planets of that particular star have already escaped the orbit of this star, right? So that could also happen. So let me click on this. That's planet 4 of 241. And let's click on this. That's star 392. No, they're completely different. How about this one? And let's log onto that star and see what we find. Okay, that's interesting. This planet is moving fast while we are traveling towards that star. So probably this planet and that star are related. So let's see which star is that. That's 241, and this is 241 planet 3. Bingo. So yes, we have found the star and the planet associated with each other, right? What about this planet? Ah, that's the planet number 3 of completely different star. Okay, but this and this is quite far away from each other. They're just in the same view but not really in the same system. So how about this one? Again, this is 241 planet 2, and this one is 241. Oh, so this and this is related. This and this is related. It's good to find a star that still has the planets around it, right? So, well, one lucky escape there. This is a completely different planet. Again, another planet. So planet, this is planet number 2 of star 183, planet number 2 of star 400. Completely two different stars altogether, but that star doesn't seem to be near here at all. Yeah, so this is uh, black hole 1, star 400, planet 2. This is black hole 1, star 400, planet 2. Um, and this is planet 2 of star 400, planet 2 of 241, and this is planet 3 of 114. Well, this particular planet is number 3 of 241, and this star is 241. So they are still near to each other. Well, not quite near, but still they are associated. But you can see that I'm finding the planets around a star. Those are not really the planets of this star as originally intended, and that's because there has been quite a bit of mix-up. I created imperfection, and that imperfection means that some of the planets might have completely ended up with the wrong star. The star might have ended up with a completely wrong or a different galactic center, and that's because of the imperfection of plus minus 5%. Okay, so I'm trying to go away from that star now and see if we can find anything else to investigate. Let's circle around. Okay, let's lock onto something here and let's circle around that. It's good to find the fastest moving object in our view. It must be quite far actually. How far it is, if you want to find out, let's go away. So you can see, well, that fast moving object is, well, has traveled quite far away. It's still moving away. So let me again zoom out a bit just to see. I want to see this circle around and see how far that has actually gone. So let's zoom out again a bit and let's see. I want to see that circling around the galactic cores and have that circle in complete view, right? That's very, very far away because that planet really escaped the galactic center in a magnificent way. Probably it might have veered very nearby a black hole. We don't know, right? We have to find a way to record those events when that's happening exactly at that moment. As you can see, there's another planet here which has traveled quite far, but that doesn't seem to be as fast as that one. Yeah, it's interesting. They are completely in two different directions, as if the momentum of the entire system has been preserved. That's another thing to investigate, isn't it? So let's zoom on to that galactic center again and see if we can find anything more interesting to report on. Oh, I love it. Well, in real life, you can never go around galaxies. It will take thousands and thousands, probably millions of years to do that physically. Unless we learn how to travel at the speed of light, we are never ever going to do that in our lifetime. Probably even at light speed, we can't do it in our lifetime, you know. Probably because if you're traveling at light speed, time stops and we stop aging and then we can keep traveling forever. Or probably we learn to expand our lifetime to millions of years and then we'll be the civilization that can go around galaxies just like this. But until then, well, physically we can't do it, but it should not stop us in our imagination to achieve the same effect, to visualize what it would be like to go around galaxies and travel around stars, from star to star, from planets to planets, hop around the galaxies and see what it would be like to travel from one place to another. Visualize it. Simulate the what if scenario. What if we increased the velocity by 5%? What if we created random defects? What would that be like? What kind of chaos do we expect to see in the galaxies? It doesn't stop us from doing those experiments because we are simulating. That's the difficult bit of physics, isn't it? Or the cosmos, right? If it was chemistry, you could add two chemicals in your laboratory and you could see the effects of it. But when it comes to physics, okay, physics, you could do a lot of physics experiments in your laboratory as well. But when it comes to cosmic experiments, how would you do that? You're not going to create the galaxies in the empty space and see how they behave in your lifetime. So how do you do that exactly? Well, the answer is simulation, right? Simulation is the savior. Well, a lot of scientists have put a lot of theories, beautiful theories. They have worked really hard on the formulations, mathematical formulations of those theories. Here's an idea. What if we could simulate all of them together? What if we could, find a way to put all those scientific theories and the mathematical formulations in a simulation and run all of them together and see whether they stack up together, which of them stand tall and which of them fall, right? We'll know when we simulate. I'd love to, uh, you know, add many of those scientific um, formulas in the simulation and see how they all pan out together, right? So it would be great to do that. And of course, I can't do that alone. And if you'd like to work with me on doing that, please feel free to get in touch and we could do something like that together. Um, and see how all those formulas, all those scientific theories stack up when it comes to simulation, right? Um, so yeah, I mean, that's all I want to talk about today. And yeah, some interesting findings in this experiment, thought experiment, simulation experiment. Probably now we don't need to restrict ourselves to thought experiment. We can have simulation experiments and we can visualize the simulation results, right? So on that thought, well, thank you so much for being with me today, and I'll sign out for today and see you next time. Goodbye.